So the first topic about how numbers are a little different in science than in math that you may have used before is that this idea of accuracy. Accuracy and precision are two words sometimes we use to describe how careful we were when we measured something. Accuracy actually has a scientific description, though, that is saying any set of measurements whose average is close to what was accepted. So if you were an archer and you shot these and they were dead on the bullseye, that's definitely accurate. It's also precise. Whereas in this example, there's a lot bigger spread. But if you look still at the average, if you had little errors on one direction versus another direction when you shot, but you looked over several measurements, you're still saying that right between all those measurements is what I was shooting for. That's still accurate, but it's not as precise. So precision is just the process of doing something over and over again in a repeatable way. More often than not, if you find that someone's really precise, they could have something systematically wrong and they could still be off even though that they're grouped tightly together. Something on the scale was missing, and so it's measuring systematically something lighter. So that kind of concept is going to be important when we communicate and write numbers to other people. Here's a common kind of an object that we might have to do, and that's to measure length. A lot of times we're going to do that with a meter stick. As you can see here, anytime you have an instrument like this meter stick, I'll bring this up to the camera so you can see, there's markings on here. I go all the way down, not to the centimeter, which is to these big markings here, but to the individual cuts between there. Those are centimeters, and then even between 1 centimeter, like 19 to 20 here, there's 10 more cuts. That's a millimeter. But an instrument is good at reporting numbers all the way to the markings, plus one more guess. So if I was looking at this pencil on this ruler here, if I was looking at the pencil on that ruler here, what I can do is I can come down here and I can look at the little more blown up version. Is that pencil tip goes all the way right to here. So, for instance, if this was an 8 centimeter sort of pencil, I can mark it down to 8.1 or 2 plus another guess. So really that should be written out as 8.26 centimeters, or to the 1/100th of a centimeter. Now, that's all fine if you're using an instrument. Some other instruments that may have markings may not be as accurate. You can see here I have a graduated cylinder. If I look closely at those markings, I can see they go down to the single milliliter, sorry. But I can still guess even at better than those if I want to figure out to the 10th of a milliliter. When I write those out, I have to reflect that. Most of the time, you're not necessarily doing the measurement. You're going to read somebody else's results, and you're going to have to report those out. Okay? Now, the last thing I wanted to mention is that if it's a digital scale, and I don't have one right in front of me, something that was digital and it reads down to the last number, digital instruments, you just have to stop where the digital instrument stops. It's like a scale that stops at the end. You can't quite see if it's a 1/10 of the way between 100th of a gram and the next 100th of a gram. So you just write the numbers that are there for digital scales, digital volume meters. Sometimes, you know, in labs like that are doing DNA analysis, they'll have it all dialed down to the microliter or something along those lines. It's very, very precise, but I can't give any more than that because there is no markings down at that level. When you get somebody else that's measured this and you're working together as a collaboration, you have to trust others, members of your crew to measure. Then you have to have certain rules about measurements and when they're accurate and when they're not. First of all, here's 4 of those rules that are mentioned, okay, in this about significance. And these significance mean just carefulness. It's not that they're important or not, it's that they're careful. So significant figures are going to be used to determine when somebody else looks at a number if it was carefully measured. The zeros, non-zeros, if they're written out, in other words, hey, this is 32.4 pounds, every number that's not a 0 is carefully measured when you see that in a written document. So then we have the zeros, and we can either talk about the captured zeros, those zeros in the middle of a number. Okay, you can talk about zeros that are on the left of a number that are only holding the decimal place. And then there's zeros to the right of the number. Again, what I'm referring to as the numbers, that is the non-zero digits and those that sandwich between. Here's the zeros to the right, or the trailing zeros. And there are 3 different rules. For carefulness, for significance, not importance, but significance, we're going to say zeros that lead, okay, or sorry, the zeros in between. Let's start there. The captured zeros, they are always going to be part. If you're careful in the hundreds place and the ones place, then the tens place has to be careful. Zeros in the left side of this number over here don't add to your understanding of accuracy. If I was going to say, well, which one's more accurate, 307 or 30700, you'd automatically say, well, it has more decimals to the right. So that's where accuracy is portrayed. These zeros in the front don't. They don't add to your understanding of accuracy, so you don't count them as part of the accurate numbers. They're important to hold a place, just not accurate. And last, if zeros on the right of a number are there, what you have to do is, here's the zeros that are trailing. You just look anywhere in the numbers. Don't worry about where the decimal is and what the zeros are to the right or left of the decimal. Here's the zeros to the right of the number, and there's a decimal, so you have to count those as part of the careful digits. So, if that's the case, what I want you to do is to go into the assignment that's posted below and just work through those first set of measurements for me and tell me whether they're carefully measured. You'll see some instruments you're going to post. And then the last one is tell me how many digits on the written ones are carefully measured. And then you can come on back.